Find the solutions of each equation mentally. So on this first one, how would I go about solving this guy? Nothing. When we solve, we got to get x by itself, right? So it's attached to the squared. How do we get rid of that squared? We square root it. Okay, so what's the square root of 4? 2. Now remember, when we solve and we have a squared, we're going to have a positive and negative version of that guy. Okay, what about on the next one? That's not going to give us a whole number. So what do we do when it doesn't give us a whole number? We're going to leave it underneath the radical. So we're going to have positive and negative square root of 2. What about taking the square root of 0? What do you get? Square root of 0. What do you get? There you go. All right, and then we learned this like way back in first semester. When we take a square root of a negative number, what do we get? Imaginary number. So we got I, right? So we'll have positive and negative I. That's throwback to like unit. All right, so another way that you could actually do this is you could look at the Y value. So for instance, our Y value is going to be 4 on this equation. So we look at when Y is 4, what's our X value? And our X value is 2. Okay, notice what our solutions are. Same thing over here, -2. Okay, if we look at when Y is 2, look at what our X is. It's roughly like 1 point something, right? 1.5-ish. Okay, and that's what the square root of 2 is. When we take the square root of 0, we get 0. And then what about -1? Well, when we look down here, is there anything that's touching this? No, it's imaginary, right? Yes, no. Okay, cool. All right, so today we're going to talk about graphing radical functions and finding the key features. So there are 2 different parent functions we're going to look at. They're called square root and cube root. Okay. So looking at this first one, square root, we've been dealing with that guy for like a hot minute, right? Okay, so looking at this, we're going to fill in the little table, and then we're going to plot those points. Okay, so if I take -9 and I plug it into this equation, so what's the square root of -9 going to give me? Not -3. Remember, if we have a negative underneath the radical, we have an I, and the square root of 9 is, y'all told me it was 3, right? So we're going to have 3I. Okay. Oh, okay. Good thought. I heard a -3. You good though? All right, on the next one, when I take the square root of -4, what do I get? 2I. If I take the square root of -1, what am I going to get? Just 1I or just I? If I take the square root of 0, what do I get? 0. Square root of 1. And square root of 4. And square root of 9. Okay, did everybody see where I got those numbers from? Okay, so now we're going to plot them. Well, we can't plot imaginary numbers. Okay, not on our real graph, right? So the first real point is going to start at the 0, 0. Where is that located? That's the origin, right? Change the color. It's going to go right here. Okay. The next point is going to be 1, 1. For those of you who are not so great at graphing, really quick, if I have the X, it's always X is written first, then Y. Okay. If it's positive, then that means you're going to go to the right from the 0, 0. If it's negative, you're going to go to the left. For my Y value, if it's positive, you're going to go up. If it's negative, you're going to go down. Okay, so, yep. What? Somebody else is borrowing it. Okay, so we're gonna plot the next point. So we got 1, 1. That means that we're gonna go to the right one, up 1. So we're gonna put a point right there. The next point is gonna be 4, 2. So we're gonna go over 4 and up 2. And the next one's gonna be 9, 3. So we're gonna go to the right 9 and up 3. And we're gonna connect those dots. Anything that has a root function is always, or square root is always going to have a starting point, and then it's going to go off to the side. Okay. Fortunately, we have Desmos, so we don't have to normally hand plot it, but this is actually how you would do that. Now, for domain, we're going to only talk about the x values that produce a whole number and not an imaginary number. So right here is where we start having our real numbers, right? So what is the x value that we start at? 0. And where does that go on to? Well, it keeps going on forever, right? Like we could plug in another number, like we could be like, all right, 16, and that would give us 4, right? So it would keep going on forever and ever. So we're going to say from 0 to positive infinity. Now, notice how I used a bracket on one side and a parentheses on the other. Bracket means we touch that point. Parentheses means we can't touch that point. It just continues to that point. Okay, so again, bracket means inclusive. Parentheses means not inclusive. Can you actually touch infinity? No. So that's why we're going to use that parentheses. Okay. For range, we're looking at our y values. What's our lowest y value? That's real. 0. What's our highest y value? Infinity, right? In behavior is going to look a little different from what you've seen in the past. So in behavior is if you were standing at 0, 0, you're this guy right here. Okay. And you look to the right, what is happening to our y values? So as we look to the right, what's happening to our y values? Where are they going? Up or down? Up, which is positive infinity. Now, as we move to the left, we don't have any numbers past the point of 0. Okay, so the way that we're going to say this is we're going to say as x is approaching 0, and we're going to say from the right-hand side, sometimes you'll see this, I'm just going to go ahead and throw it at you. From the right-hand side is positive, from the left-hand side is negative. So as x approaches 0 from the right-hand side, so as we're looking this way, what's happening to our y values? Where are they getting closer and closer to? 0. So y is approaching 0. Okay. We could say as x is approaching negative infinity, y is getting closer to 0, but that's not necessarily a true statement because those x's don't go on forever. Okay, are we okay on domain, range, and in behavior? Yeah. So domain is your x values, right? So how far to the left do we have 0? And then going on to positive infinity. We're only looking at when we get a y value, right? Okay. Intervals of increase, where is it increasing? Well, it's increasing the entire time, right? When we look at increasing and decreasing, you almost want to think of like a roller coaster. So if you're starting right here on the roller coaster, are you going up or down? You're going up. So where is that happening? Well, it's happening from 0 to positive infinity. So the entire time is going up. Is it ever going down? No. So we're gonna play it not applicable or not. It's a little tricky, just because we naturally don't know like what the cubic root of something is. So I'm gonna show you how to do this in Desmos so that you don't have to do this by hand necessarily. Okay, so when you put this into Desmos, what it's gonna look like. Okay, is when you come in here, you're gonna hit this little keyboard button down at the bottom, and you're gonna look at the functions, and you're looking for something that says, there we go, this little nth root button. So you're gonna click on that, and notice how it puts the little like cursor right here. You're gonna type 3, and then you're gonna put x underneath the radical. Yep. Say again. So Desmos.com, and then you're gonna click on graphing calculator. Have you not used Desmos before? Yeah, you can use it, and you can use it on normally you can use it on your tests. Okay, so now that we're here, we can go ahead and hit this little gear button up at the top, and then hit this little table button as well. Okay, now they asked us for specific x values. Okay, they asked us for specific x values. So we're going to plug in -9, -4, -1, 0, 1, 4, 9. So we're going to come over here, and instead of -2, we're going to say -9. We're going to come down here. We're going to say -4, -2, 0. All those numbers that they have listed right here. Okay. Was 2 not included in that? No, it wasn't. That's okay. Okay. So you're going to copy these numbers onto that little chart. So go ahead and take a second and write those down. All right. So your paper should look like what's up on the board, right? Okay. Now for cubic functions, your domain is going to be from -infinity to positive infinity. And your range is also going to be -infinity to positive infinity. Remember, domain is your x's. Okay, so that means that I can plug in any x value and get some y value, right? For in behavior, going to be kind of similar to what we've seen in the past. As we look to the right, what's happening to our y values? Where are they going? They're increasing to positive infinity, right? As we move to the left, so as x is approaching -infinity, what's happening to our y values? Decreasing. Okay. Now, everyone is always tripped up by this increase and decrease stuff. I need you to think, if you went to Six Flags, you got on a roller coaster, this is you. Okay. Would you be going up or down? Well, it's only like when you go down, right? Yeah. Okay, so is there any part in time where you're going down? Yeah. Okay, but is there any on this graph? No. Okay, so this is increasing the entire time, right? So we're gonna say -infinity to positive infinity, and there's no decreasing. Through. Okay, so on these little sliders, what does A do? Just kind of summarize it for me. It changes the yellow line, okay, but what does it do? Like, does it move it up and down? Does it move it side to side? Does it move it up and down? we're gonna call that reflects, right? You know that word from geometry? Yeah. Okay, what about H? What does it do? What does H do? It moves it side to side, so it moves it left and right, right? What about K? What does it do? Up and down, good. Okay, so A reflects, okay, or has it like up and down movement, kind of. H is moving left to right, and then K is up and down, right? Okay, let's go ahead and look at slide 2. Okay, playing with the sliders to manipulate the graph of the cube function. Okay, so we're doing the same thing, but now we're dealing with a cube function. So what does A do? What does it do? It kind of looks like it's rotating, but it's like reflecting it, right? Like it's putting it one side on the bottom, one side on the top, right? What does H do? Left, right, and then K is up and down, right? Same thing that we had on the last one, right? Okay. So using the graphs on the previous slides, describe the transformations. Okay, so go ahead and tell me in here, type out what those transformations do. We just said them out loud. All you're doing is just putting it on your laptop. Take a second, type that out. So you should be on slide 3. So on slide 4, it kind of gives us a summary of what's going on. Okay, so y'all know like the parent functions, right? Like you've heard that phrase before, parent functions. Yeah. Okay, so those are the OGs. Okay, the parent function is where it always stems from. Okay, so you've got the square root of x right here. So if I had a vertical translation by k, it would look like this. Obviously, we would have a number for k, but that would be shifted up k units or wherever k units. Horizontal translation would be this h underneath the radical. A vertical and horizontal translation would look like this. And then a reflection in the x-axis would have a negative number out front. And then we're going to talk about something called stretches and shrinks, but we'll get to that in just 1 second. Okay. So go ahead and take a second, graph this square root function. Okay. If you're like, I have no idea how to graph this, guess what? We have Desmos. We have the technology. So all you have to do is type it into Desmos graphing calculator and then draw it over there. Okay, so go ahead and take a second, try this on your own. All right, so I personally am not gonna sit here and like hand graph this out. I'm gonna use Desmos, right? So when I go into Desmos graphing calculator, when I want to type this out, I'm gonna say negative, and there's actually a shortcut to type the square root. You can say SQRT, and it automatically does the square root symbol. Okay, you can also find it in your keyboard. That's okay too. Okay, and then you're going to type that x plus 4, and then out of the radical, we have minus 1. So your graph should look like this. Okay. And if you want to look at the table's right here. Now they asked us for the domain, and they also asked us for the transformation. Okay. When they're asking for transformations, they're asking you to compare it to the OG. Okay. So what I mean by that is we're comparing this to the square root of x. So from the blue line to the red line, what happened? Okay, so again, I'm looking for those little keywords. So you told me that it was decreasing. So we're gonna call that a reflection across the x-axis. Okay, and the reason why we're gonna have one of those is because there's that negative filling out front. Does everybody see where I got that from? Or there's going to be a reflection across the x-axis. Okay. Now, did it move up or down? Yeah. Where did it move to? Down. It's not 2 units. It's going to be 1 unit. Okay. So looking back in here, we've got this negative 1 chilling on the outside. So this is telling us that we're going to move down 1 unit. Okay. I know on here there's 2 lines. You gotta be careful. This says -2 here. So -1's right in there. So, all right. It move left or right? Okay, which direction? Left or right? Left. Okay, and it moved left how many units? 4. Okay, so we're gonna say it moved left 4. We're never gonna say a positive, or we're never gonna say a negative number with that. So we moved left 4, we reflected across the x-axis, and we moved down 1, etc. Okay, so I'm gonna go ahead and I'm gonna get rid of this parent function, and we're just gonna look at the red this time. Okay, so we're gonna try to find the domain, the range, the in behavior, the increase, and the decrease. Okay, so for domain, what's my farthest left x value? Yep. What's my farthest left x value? Somebody said it. -4. Okay, and then how far to the right does it go? I mean, it just keeps going, right? Remember, with these graphs, you got that arrow, keep going, right? So we're gonna say it's a positive infinity. Again, notice how I use brackets and then parentheses. That is important. For your range, what's my highest y value? Well, my highest y value is going to be this -1, right? Say again? Yeah, you do. You see where the enter button is? It's like 1 button up, 3 buttons to the left. You see it? Okay, so for range, our highest y value is going to be -1, and our lowest y value is going to be -infinity. So in behavior is when you're standing at 0, 0, and you're looking to the right, and you're asking yourself, is it going up or is it going down? Well, it's going down, right? Then we're going to look to the left. Well, the farthest left x value is -4. So we're going to say as x is approaching -4 from the right, our y values are going to -1. If you got on this and it was a roller coaster, would you be going up or down? Down. That would be the worst roller coaster on the face of this planet, right? So decrease, and we're going to start from -4 to positive infinity.